So let's look into the SI unit that we need to use when we're talking about magnetic fields. So it's named after the person, right? Named after, yes. So it's correct, Tesla with a small t or capital T in this manner, right? It's the same Tesla. We're talking about the same person whom you guys know of if you know of. So how do you define one Tesla? So for that, I should start over here actually. So we have seen this, that the magnetic field is equal to this, right? Your free space constant, and it depends on the length of the wire, current in the wire, angle which it is at, and the distance. You always remember the formula this way, it will be easy. Now, what do we have in our hand? Well, dl, I, theta, r. All of this is in our hand. So for dl is equal to 1 meter, right? I, which is equal to 1 ampere, and sine theta or theta is equal to 90 degree, and your distance 1 meter. What happens? Yes, all of this will go to being 1, all in all, right? So you're left out with mu naught 4 pi. So let's substitute mu naught, which is nothing but 4 pi into 10 to the power of minus 7. Right, guys? So what will happen to dB? dB will be equal to 10 to the power of minus 7. Right? So basically, for a length of 1 meter and a current of 1 ampere, when the point is at an angle of 90 degree, so basically you have a wire of 1 meter and you have a point at an angle of perpendicularity, and the current is 1 ampere, length is 1 meter. And so on and so forth, and distance is also 1 meter. What happens? This will experience a force of 10 to the power of minus 7 Tesla. As simple as that. And so we can tell that 1 Tesla is 10 to the power of minus 7 times the magnetic field produced by a conducting wire of length 1 meter carrying a current of 1 ampere at a distance of 1 meter from the wire and perpendicular to it. So with all of this condition, it is 10 to the power of minus 7. For it to be 1, a simple cross multiplication, and we end up that 1 Tesla is 10 to the power of, actually, sorry, it has to be so. 1 Tesla is 10 to the power of 7 times the magnetic field produced by a conducting wire. Makes sense. So let me show this. So I'm using proportionality. Sorry, I kind of confused you guys. So we have dB and here some unit, right? Some value. So basically, if I multiply this value with 1, dB is 10 to the power of minus 7. If I multiply this value with 10 to the power of 7, dB will be 1. Is it not? So basically, this constant is what we are talking about over here. Right? Simple proportionality. So what should I multiply? Or if I multiply 10 to the power of minus plus 7 over here, how much is x? And this is directly proportional. So what is x? X will be equal to 10 to the power of minus 7 into 10 to the power of 7 divided by 1. So when I do this, I'll get 1, is it not? And that's what is 1 Tesla. So 1 Tesla is 10 to the power of 7 times the magnetic field produced by a conducting wire of length 1 meter carrying a current of 1 ampere at a distance of 1 meter from the wire and perpendicular to it. Right? Thus making the angle 90 degree. So that is your 1 Tesla. Okay, you guys can copy this now.